as the components for or the utensils for your kitchen are being produced. It is process of changing flat pre-cut metal blank into hollow vessel. So, the blank which was taken for making this hollow vessel must be about something like a circular coin sort of a thing, and this will require an shaving operation later on to remove the excessive material from the brim. So, this was about your drawing. Then next is your coining operation. In this operation of this is the operation of making impression and depression on the metal piece. Over here you can see that the depression has been made on the surface, whereas there has been upwards impression on the right hand side over here on the coin. So, if we want something on a shape to be coming up on the face of the component, we can do it with the coining operation. So, next non-cutting operation is of the bulging. So, over here you can see a pipe or a vessel, hollow vessel has been bulged over here along the circumference in the middle. So, this kind of ring is formed, which is due to bulging. It expands the cup along a narrow band and at the same time reduces the height. So, we can see the height of the container will be reduced after the operation, and it will be expansion in the middle of the component almost. Then next is your hemming. This is operation for joining two sheets. Over here you can see the upper sheet is going like a U over here on the end, and the lower sheet is having a U kind of a thing on its right hand side, and when they combine, when they get assembled to each other, after this is pressed over here. Either it can be done in single stroke by punching over it or pressing over it, or it may be passed through roller, wherein these things will come in contact with each other, and it will be a leak proof joint over here, which may be used for making small containers for food and all, or juice containers for their preservation. The next operation which can be done in non-cutting press operations is seaming. This is the operation of pushing the material inside oblique outside all around the periphery. So, over here it is an outside bulge, and over here on the right hand side it is an inside bulge. So, these are called seaming actually. Next is curling. If you have a straight brim over here on the vessel, if you curl it from upside towards downwards, then this is called the curling operation, which is evident from this drawing over here or the picture. This is the operation of the turning the edge inside. Over here with the diagram is depicted a die in which we can see different parts. We can see there are some guide pins over there, then we have the strip up pilots over there, then spring is there, this one, and die plate is there. Then we have the bottom plate over here, which is having some holes for passing of the punches, the reverse punches are there. Then this one is the bottom thrust plate, then clamping bush is there. These are the guide pillars. These are usually 4 in number. On the right hand side we can see one, on the left hand side we can see one. Then we have a top plate over here, we have a guide bush for this, and we have a stripper plate over here, guide pin is there. So, all these kind of parts are part of your die which is used in press working. Over here we can see a small press that is being used for making keys. So, these are the contours over here which you can see some keys are being formed, and the layout is such that one key is kept upwards, the head upwards, and the next key is kept with the head downwards. So, this is actually a sensible management for placing the component formation. This has been planned in the designing, that the layout will matter in this way. If the orientation of the keys is kept like this, one upwards, one downwards, then the lesser of the material will be used. Over here we can see this purple plate over here is the fixed plate, while the upper plate over here is the moving plate. Then we see the guide pillars over here. One small guide pillar is there, number 2 small guide pillar, number 3 guide pillar. Then the strong guide pillars are over here. Only one is shown over here. So, actually these are not the these small ones are not the pillars, they are actually stoppers for this stripper plate. This orangish color plate is the stripper plate, and it is guided on some pins. It is held with some springs actually, and the material is flowing through this gap over here. It is fed from the back side, and as the operations are being done, this strip will be pulled out in this direction after the formation of the piece. So, you can find some formulas by thumb rule which are used in calculating the forces required for press work. The simple formula will be S into P into T over here. So, where S is shear strength of component, because in a press operation when we are cutting something, then shearing is going on. So, we are more interested in the shear strength of the material. Then P is the perimeter of the component in millimeters. Then T is the thickness of component in millimeters. So, in this way we are able to find out whether the press is having enough capacity for our component or not, and the capacity of the presses which we use for making components comes in actually in tons. So, a machine may be 10-ton machine, it may be 50-ton machine, it may be 150-ton machine. For higher capacity machines, the technology which is used is the hydraulic pressure. For smaller ones we use flywheels. So, the kind of ball bearing cages which we use in these press dies is a cage over here you can see, and there are balls of the ball bearing kind of a thing. These are very hard balls, steel balls, and these are fixed into these cages, and this forms the bearing. These are used where the guide pillars are again and again reaching into this and out of this for the axial motion of the plate. So, because this operation is very repeated, it contains lot of strokes. You can think that sometimes this press operation may take about 0.2 seconds only, or sometimes it may take half second only. So, the assembly and disassembly of the fixed plate and moving plate is very quick. So, for that reasons we need this kind of ball bearing cages, because solid bushes won't work well over here, they will require a lot of lubrication, but these are almost without lubrication, they may not require lubrication over here. Another component which is very commonly used for these dies is this sleeve bush for die sets. You can see the upper portion of this bush of die set is having lesser dia and a small step, whereas the lower portion is a longer length and a higher dia. So, when we press this into a plate, it will be stopping after reaching this upper gap. So, it gives you an idea what kind of components are being used in the press. Then the materials which are being used for this press work, on the left hand side we see the application, and then we see the AISI steel type group, and here is the required hardness. After the heat treatment we will require this kind of hardness for good operating conditions for the press tool which we have designed. So, if we want that the press tool to last long, then this kind of recommendation is required to harden the components to this level. So, for blanking dies and punches, the steel may be used of group O, A and W, and the hardness may vary from 58 to 60. And for blanking dies and punches, for long run, they may be used from A, D and M group, and the hardness may vary from 60 to 62, and in the M group it will be 61 to 63. And in the drawing dies over here, you can see the hardness of the component is not very much, because we require more hardness in the punches or in the blanking dies. So, we can see the hardness, Rockwell hardness required is 52 to 54 for drawing dies for H group, and for cold extrusion they are nearly 60. So, this is the kind of hardness we require for the dies. So, there are a number of types of springs which we have to use for these press working dies. So, over here the company has shown this RLL, some company must have made this one, and they are giving the specification according to this chart. This is a rectangular spring over here. For light work, we may use spring with circular cross section, and if the load is more, then we prefer using this kind of a rectangular cross section. Over here, this material is this spring is provided in the green color, and if it is of a blue color, that is for medium load, and if the spring provided is of red color, that is for heavy load. So, over here this spring is actually in green color, so this is for light load. So, we can make a choice with what kind of a spring we want. From this data we can calculate what spring will be suitable in what condition. So, over here is the shown the raw material in a strip form in which these keys are being formed, and these notches over here, small removal of material just shows that when the strip proceeds, it proceeds in steps, one by one it proceeds, and the key is being cut, and these are in, you can clearly see the orientation of the keys, one upwards and one downwards, which is a sensible layout. And this is the die disassembled over here. You can have a clearer look of the assembly of different components in the press. So, you can see some guide pillars over here. These are the bushes made from some different material. This is the base plate. Over this plate is going to be fixed up. So, I hope you are benefited by this lecture today, and see you in next lecture. Thank you.